Welcome to the second stage for your interactive session. That was an amazing talk, as we always expect from you. This is my first session that I'm hosting today, so I'll introduce myself to the audience as well as to you, Andrew. I'm Jon Krohn. I'm Chief Data Scientist and co-founder of an AI startup called Nebula, but I'm perhaps best known as the host of Super Data Science, which is the world's most listened to data science podcast. And I'm delighted that for 3 years in a row now, I've been hosting sessions here at ScaleUp AI. So thanks, Insight Partners, for inviting me back again. Andrew, in your talk, you discussed how your team found that with GPT 3.5 and an agentic workflow, it can outperform a more advanced foundational model, such as GPT-4, with a zero-shot approach. How should companies balance their investments between pursuing more powerful models versus leveraging more effective agent architectures?
I think almost all companies, with the exception of a few, giants, should be focusing on building applications using agentic workloads. If you have an extra few $1 billion to spare, by all means, go compete with OpenAI and Anthropic and Gemini or whatever. I think that in all seriousness, you want to do it, go for it. Just plan to spend a few $1 billion maybe. Um, uh, uh, but I think that for most businesses, is a very there's so many opportunities to build applications. And it turns out that if you look at the use of generative AI, the cost of using these models is falling rapidly. So over the last year and a half, it's fallen by maybe about 80% year on year. So I find that, kind of 2 years ago, there were teams worried about, oh, GPT-4 is kind of expensive, but the prices are falling so quickly that I would advise to worry much more about building something valuable. And then I think there's a good chance that the use of these APIs to use Gen AI will just become cheaper over time. And there are companies spending many millions of dollars on Gen AI APIs, so it can get expensive, but the vast majority of businesses I see have generative AI builds. If you build an application on top of OpenAI or Anthropic or these other APIs, I see so many businesses that are getting so much value out of it. And frankly, the bill they're sending, is so small that you'd be surprised at how small the number. You won't be surprised, John, but I think many people will be surprised at how cheap
Well,
it
it
is.
makes perfect sense. And yeah, so unless people do have billions of dollars to spend, let me move on to a related question where, assuming that people aren't going to be trying to train their own LLMs themselves, if you're an enterprise, should you be thinking more about always trying to use the latest and greatest LLM, or be thinking about grabbing the best agentic workflows? It seems like there's kind of a trade-off there between cost and efficiency, because yes, while costs have gone down dramatically, say by 80%, you could save a lot of money by working with GPT 4o mini instead of GPT 4o. And so if I can be using that cheaper GPT 4o mini and getting better results by leveraging a more effective agentic workflow, it seems like, do you think that's the way to go for the most part?
I would say don't worry about. I feel like as a general suggestion, I would say don't worry about the price of the LLM
Okay.
to get started. And I think um, for development purposes, is actually it's not impossible, but honestly, so I still do a fair amount of coding myself, right? And sometimes I would be spending all day on the weekend coding, for many hours, experimenting, and then I find at the end of the day, I just ran out like a $5 OpenAI bill,
Yeah, yeah,
right?
yeah.
And now it is possible. There are some agentic workloads that can get more expensive. It is possible to run up, tens of dollars, maybe low hundreds of dollars, but it's actually cheaper than you would think. And so what I advise most teams is the hardest thing is just building something that works. That's still pretty hard. So use the best model, build something that works. And after you have something, if we're so lucky to build something so valuable that its usage is too expensive,
Hmm.
that's a wonderful problem to have. A lot fewer people have that problem than I wish. But when we have that problem, we then often have tools to lower the costs. But I think that uh, a lot more people are worried about the price of using these generative AI APIs than is necessarily the case. And the most important thing is, so I would say use the best model, use the latest best model, just build something that is valuable, and only after you succeed at that, and only if it turns out to be expensive, then work on the cost optimization afterward.
Okay, nice. And then so if you are lucky enough to get to that stage, maybe there's a balance of experimenting both with lower cost options like moving to GPT-4o Mini, say, or experimenting with different agentic workflows and just trying to see which gets you the best results for your use case.
Yeah, yes. And just be clear, there are teams that have, found that they were spending too much money on these and then spend time optimizing it. So you can use cheaper models, you can take a smaller model and do something called supervised fine-tuning to optimize it for your own workload. So there are multiple tools, but I think using these other tools optimize costs before you've, first built something valuable, I think that will most likely be premature optimization, and I would shy away from that.
Nice. That's a great answer. Digging into agentic AI a bit more, which was a big theme in your talk and something that you said is maybe the technology we should be most excited about at this time. Going back to a Wired article in 2013, you mentioned how in the early days of AI, the prevailing opinion was that human intelligence derived from thousands of simple agents working in concert. This is what MIT's Marvin Minsky called the society of mind. But then, you mentioned later in this Wired article that you stumbled upon the single algorithm theory popularized by Jeff Hawkins, which led you to deep learning. Now, 11 years after that Wired article, are agents and multi-agent systems in particular marrying both of these concepts together, where we kind of have both ideas now blending together and providing powerful tooling?
It's an interesting question. Boy, I totally forgotten about that. Uh, well done digging it up. So I think that uh, what's been remarkable about the large language model revolution is how much of it is because of one or a relatively small number of algorithms, namely the transformer neural network. And it turns out that the reason large language models, which are based on a neural network called the transformer network, the reason they can demonstrate such amazing capabilities is, I want to say a lot of it is because of the richness of the data we feed it. So there's this hypothesis, not proven, but this hypothesis that even human intelligence, the human brain, a lot of human intelligence is due to one or a very small number of algorithms that when fed all the richness of data from the world allows us to learn to do all of these amazing things that humans can do. And then as children grow up into adults, they also really, to a large part, I think because of the data they were fed, maybe a little bit of genetics, maybe a little bit of the algorithm, but really a lot of data, the same infant brain could grow up, right, to become a doctor or an architect or a software engineer or whatever. And that's the data and the interactions. And I think agentic workflows, always dangerous to make analogies between AI and humans, but I think there is a little bit of that getting the AI models to specialize a little bit for different tasks based on how we prompt it or how we feed it additional data to do specific job/role-based tasks.
Nice, yeah. And I appreciate that you loved us digging that out. I wish I could take credit. I have an amazing researcher, Serge Massis, who I have to give credit to for pulling out that question and that idea. I want to move on to large vision models now as a topic, which follows from that 5 key AI trend slide that you kept coming back to in your talk. So this is particularly related to the image processing revolution that's coming that you mentioned on that 5 key AI trends slide. So Landing AI has a product called Vision Agent that led the way in this image processing revolution trend. Can you elaborate on why planning, using multiple tools, and code generation are so crucial for building effective vision AI applications and how Vision Agent addresses these challenges?
Yeah, thanks for asking that. So, um, excuse me. I think the vision revolution is coming a little bit after the text processing revolution. And it turns out that large multimodal models, they're, at least today, they're kind of okay at interpreting images. But when I mentioned the way we write text prompts in a non-agentic workflow, that's a bit like, ask people to type the essay from the first word to the last word in one go. The way that large multimodal models or vision language models are used is, if I imagine that I want you to solve a task, I could say, maybe here's a picture, take a glance, give me the answer, right? And there's some things where you could do that, where I don't know. For example, if I asked you to, yesterday I was doing a demo of counting the number of people on a football field, on a soccer field, and can I show you a picture of a bunch of people and take a glance, how many people are there? It's actually hard to do. If you ask me to count the number of people on the scene, I count 1, 2, 3, 4, 5, and that's more of an iterative agentic workflow rather than, here's a picture, what's the answer, which would be more of a zero shot, just type out the answer. And so what we found was that if we generate a plan that is expressed in code to say, these are the tools, these are the function calls, and I'm detect the people one at a time, and just count how many people are detected. It's a very simple plan. But a simple plan like that expressed in code can process images much more accurately for many kind of mission critical image tasks. And we found also that for a lot of the image vision workloads, writing the code required going to find the right library, the right open source model, integrating that. There's a lot of this kind of crafty, annoying coding work that we could do, but it takes us like half a day. But we could write an agent to write a lot of that code for us, to come with a plan, write the code, to express the plan, and then test the code. And so we found that to really lower the bar for developers to get a lot of the high stakes, very important visual AI types of questions answered, and hence the vision agent. Still a lot of work to do there, but I'm actually quite excited at the number of users that are using it successfully to build software for visual AI tasks.
Yeah, it is exciting to see how this is going to accelerate. I 100% agree with you that the text processing revolution is something we're in the midst of now, and people are only beginning to realize those applications. And things like the work that you're doing in Landing AI is going to be the next big thing for sure. Having those extra modalities provides so much more optionality in real-world applications. I have one last question for you myself before I get to some audience questions. And this is related to your fifth and final key AI trend on that same 5 key AI trend slide that I was just mentioning. And this is related to unstructured data. So you've previously talked about how by volume, most of the world's data are unstructured. And so with the rise of generative AI, we're now able to tackle this vast amount of unstructured data. With the kinds of technology that you were just talking about with Vision Agent and other large vision models, how do you see visual AI transforming industries outside of traditional use cases like manufacturing and healthcare? And what untapped areas might benefit most from these vision capabilities?
I think there'll be a lot. And I find it, I'm going to give that unsatisfying answer. It's a little bit like, where will electricity be used? It's like,
Right.
boy, that's a scratcher because it's so general. But maybe I think that definitely manufacturing, I think robotic automation, including self-driving cars, that will be revolutionary for. I think healthcare, I think security. And then maybe, hey, but am I able to screen share? Can I share something? Can I screen share? Can people see this?
I don't know the answer to that question. I'm looking around the room.
Does it work?
Yeah,
People see it?
I can see it. And
Oh,
yeah, I'm getting a thumbs up from backstage.
oh, cool. Awesome. Right. So actually, this is actually a demo that we just put together over the weekend, Landing AI. But this is a video retrieval task where we use a vision agent to write code to index and retrieve these videos. So actually, let me just I don't know. Let's see, Gray Wolf at actually skier. So this is a little demo um, that has. So it turns out, see a lot of businesses with tons of videos, and they just sit in blob storage in the cloud. But using a vision agent, you can write code, write a demo to index these videos to help you find these. And I actually think actually a lot of media companies with a lot of, well, this is raising my heart rate. All right, right. And so shown UI in green, where the parts that are skier airborne, and then these parts are not skier airborne. Or let's see, Gray Wolf. I just tried this over the weekend. See if this works. But so I find that we've actually found a bunch of so there's a gray wolf at night. The UI shows in green where it's found it. If I click somewhere else, there's no gray wolf, right? Elsewhere, also bear, or black luggage, right? So I actually have been traveling a lot these days, but um, you know,
Gotcha.
But
Yeah, that's
it turns
very
out there's
cool,
a lot
Andrew,
of
to see.
black luggage, but with rainbow
Um,
strap.
I'm going to give you one audience question, Andrew. Since we had a number come in, and my personal favorite that's come in is how would you mitigate the risk of users indiscriminately relying on probabilistic answers generated by agents? So if you have an agent powered by an LLM, you're going to be getting probabilistic answers. How do you mitigate that risk relative to the more deterministic answers that you would have retrieved in a more kind of classical keyword search or like a Google kind of search?
I do wonder how deterministic some of the deterministic things are.
Right.
So I think machine learning in various forms has been working, in many industries the last 10, 15 years. And I think a lot of machine learning answers are not fully deterministic. And even web search is based on machine learning. And it's actually hard to predict exactly what a given web search will output. So I feel like part of it will be user training, which maybe isn't a popular answer because that's hard, but I think some of it will be user training. And I think some of it will be putting in place the guardrails and the mechanisms that make these safer, even for less trained users. So for example, common design pattern in GenAI workflows is a confirmation flow, where before we place an order for a user, right, to charge the credit card and ship a product, we'll often not have the AI just say done. We'll have it, generate an API call with a pop-up modal that says, do you really want to buy this? I'm about to charge your credit card $20. Please hit yes or no. And with that type of confirmation flow, it makes it safer that the LM won't just charge your credit card without you explicitly saying yes to this type of. So I find that there are these design patterns that can kind of guardrail and make the AI safer, but I think it'll be a mixture of software improvements and UI improvements with guardrails, as well as some amount of user training. And I feel like, when after ChatGPT was released, there was some bad episodes, right? Like I guess widely quoted, there's a lawyer that quoted made up cases and a court filing, got in trouble for that. And then that was really unfortunate. And one side effect of that was, a lot of lawyers learned to not do that. So that actually had a massive training effect across the industry. So yeah, I think it might be like that. Just one thing. I don't want to pretend AI can never make a mistake. It definitely make mistakes. Can't use it everywhere. It's definitely unreliable in some places. I feel like the hype about how bad it is overblown.
For
So while
sure.
it's far from perfect and it does have problems,
Yeah.
I think the number of times I see AI not get shipped that we can't use it because of these problems is actually much less than one would expect.
I think that there's a lot of memory of those kinds of early examples prominently in people's minds, like exactly the lawyer who brought fake cases and trials to a real trial that had been generated by an AI system. And so we're kind of used to those stories, but today the systems are so much better than they were a year ago or 2 years ago. Hallucinations are so much less of a big deal, and I think that's going to happen more and more. Andrew, thank you so much for taking the time with us today. We are unfortunately out of time. I had more questions, the audience had more questions, but we really appreciate you taking all the time that you did for us today. Thank you, Andrew.
Thank you so much. Thanks, everyone.